Why do you think these failures and forensic investigations, these seem to resonate a lot with, well, obviously the technical engineers, but also the
Yeah.
public. The general public is really interested in that. Like, why do you think that is?
Engineering shows that talk about catastrophes and disasters, they do extremely well, right? And there's always an iteration of it. And I think part of it is because, ever heard people like it's hard to like look away from a car crash, or it's hard not to,
Mm, yeah.
see a fire burn. Like there's just something I think about, wait a minute, that's not supposed to happen. That is just attention grabbing, right? For one.
Engineering is grounded in precision, but when that precision fails, structural forensics steps in to uncover what went wrong. Whether it's due to design flaws, material defects, or environmental stressors, understanding these failures is key to preventing them in the future. A collapsed building, a compromised bridge, these aren't just technical puzzles, they're stories that need to be told. Today, we're not just exploring the science behind structural failures, we're also talking about how we can communicate those failures. To help us unpack that, we're excited to welcome back Dr. Nehemiah Mabry, Ph.D., PE, CEO, and founder of STEM Media Incorporated. You may remember him from his appearance on the Engineering Career Coach podcast, now known as the AEC Leadership Podcast, where he talked about the importance of STEM education and inspiring the next generation. In this episode, Dr. Nee returns to share how his work intersects structural engineering, storytelling, and media production, from uncovering real-world failures to building public trust and empowering future engineers. He will share with us how technical expertise and creative communication can go hand in hand. I'm your host, Matt Picardal, and this is the Structural Engineering Channel. Dr. Nee, thanks so much for joining us.
Man, are you kidding me? Of course. I'm happy to be here.
Yeah, I know I told you before, but I've seen you on some of the episodes on YouTube and other social media, I think like on TV as well, talking about engineering and buildings as well. Big fan of that. I also I was really fascinated about how you got started in your career in engineering and where it's taken you so far.
Yeah. So I've told this story, I don't know, a gazillion times about how really didn't know what engineering was until my dad recommended it to me. And he was around like 11th grade in high school, which is late by today's standards because, you got STEM programs that start in preschool these days. But, I was able to hear about this thing called engineering, and I applied for this NASA high school summer research apprenticeship program. Got in, loved it so much that, I said, hey, I'm going to do it next summer. There was no program next summer, Matt, but I volunteered. I emailed every single person I met during that first summer and said, just let me come out, work in the lab. I would love to do it. And sure enough, I got more exposure during my volunteer summer than I did during the actual program. And it just kind of took off from there. And going back to my father, telling him that, hey, engineering is dope. I love it. Thank you. I know I don't listen to you all the time, but here's one that I think you're onto something. And come to find out that he actually started engineering when he was in college, but he didn't finish at the time. And the cool thing that happened is that he decided to go back to school while I was also in college pursuing engineering and finish his
Oh,
engineering
wow.
degree a little before me. I was a little jealous. I don't know how he just went back to school and beat me to the finish line, but he did. We even took one class together. We were at two different schools, but we took a summer class together. And really that just not only confirmed sort of my start in engineering, but also seeing the value of symbiotic encouragement, inspiration, seeing people that, you can relate to, aspire to do things that you yourself aspire to. That's really what I also got from my father in that beginning of my story.
That's really cool. Yeah, I know for me, it was my dad was electrical, and I remember we were watching documentaries about this one was like the Taipei 101, I think the tallest building at the time,
Yeah.
and them solving those engineering problems. That's what kind of got me just like, oh, there's actual jobs that solve these real world problems that almost seem impossible at the time. And yeah, that's when one of the things is looking up those engineers, civil and then structural engineers. So it's really cool.
Indeed. Indeed.
And how did you get into STEM media? And I believe you also worked with structural forensics too, right? How did those two come together?
So that's more recent. Yeah, the forensic piece. So originally I went to school studying structural engineering, civil engineering, structural engineering. Hence, this is the perfect platform. And I had my internships, because internships are a big deal when you're in engineering school. My internships though were in the area of aerospace because of NASA. So I started at NASA, went back and volunteered, got into a summer program. Doing it so many consecutive times, it morphed into really like a part-time job year round for me. And so like the first, 8 years of my career was aerospace applications, but in school studying civil structural applications, which are really not exactly the same thing. The basic principles are, but when I decided to go for my PhD, I decided to look for a graduate school that had similar research that can combine some of the principles of both aerospace, and particularly that is like structural health monitoring, embedding sensors, and things of that nature. But then also this composite material, which was being used to like rehabilitate and strengthen bridges, mat bridges. So that was my research, right? And that led into a career of bridge design engineering. So I did bridge design engineering once I finally got out of space. I did bridge design engineering for about an equal amount of time, about 7, 8 years. And that was happening in parallel with this passion I had for inspiring, elevating, and empowering others in STEM. And so that's where STEM media, my what started as a personal extracurricular activity, but morphed into a business. That's where that came from. That's where I came from. So it was just kind of very early on. I would go into the lab or go into the office, do actual technical work, but then also find opportunities to create content around it, find opportunities to speak to students around it, find opportunities to motivate people to also achieve the next big thing in STEM.
Yeah, I think that's such a huge thing, especially nowadays with social media and the way people consume content. And if there's more engineering content out there, I mean, essentially that's how I got into engineering. There was a documentary on TV, but
Yeah,
now it's all Instagram and Netflix and whatnot. But if you see engineering things like that, that could inspire the next generation, I'm sure it did to many others
absolutely.
besides myself.
And I love that you say that because we all, I wouldn't say we all, but like a lot of us are inspired by those documentaries, by those public educational shows, right? Those discovery type shows that allow us to um, see this creative ways that science and engineering is presented. Well, there's a whole generation that's growing up with social media, and to them it would just be the people that they follow, the people that pop up on their thread, right? Those are going to be the people.
Yeah.
And so we are really the modern day version of what inspired us by putting out these podcasts, by putting out these videos. And while I didn't think of it that way exactly, I realized that there was value to be had in just creating content that spoke about it instead of just doing it itself.
Yeah.
Yeah.
What about I know I think you have a kind of a unique experience. So you were at essentially aerospace industry first, right? And then
Yeah.
transitioning to civil. How was the transition? I know you mentioned it was different. Like, I guess one example of how is it different than maybe structural engineering a bridge versus working in the aerospace industry?
Yeah. How's it different? That's a good question. So while nothing is truly static still, right? Because you're building bridges and it all is going to interact with the environment. We are still primarily trying to keep our structures in place, right? We don't want our bridge floating out to space. We're not trying to make, our houses entirely movable, right? They're just different things that we're trying to do in civil structures. Whereas the purpose of aerospace is this thing needs to fly. This thing needs to interact with air that's flowing by it at certain speeds, whether it be laminar over one side or turbulent on the other side. So basically, what I'm saying is like the primary stresses that we account for are a little different, right? So if we're dealing with structural engineering, there's gravity, there's the weight of the materials. Obviously, there's going to be some wind that's lateral. There's going to be seismic, which happens at the base. When you go into aerospace and even, looking at aeronautical, right? stresses could be all different ways, shapes, and orientations. So in a way, I will admit, right, and I've had these debates with some of my aerospace colleagues, that in a way I would say that it is a little bit more complex and can be more difficult when you're trying to fully analyze every possible interaction with the force of something that's going to go into space. I mean, you're talking about impact, for instance. I remember there's times at NASA where there were just tests where they would shoot, high projectiles, very small projectiles at some material just to see how it impact, right? Trying to look at space debris. So when this thing is going into space, like things are going to run into it, right? At speeds, at least on par with the velocity of the spacecraft. So I would say aerospace has a lot more things to account for, and it's really very necessary for them to like think of a lot of different what ifs. Whereas structural engineering, if we're not doing anything innovative, which we do innovative designs and concepts, but you can go through a whole structural engineering, civil structural career so far of what I've seen, and stay within sort of a very known category of what winds and force or what forces and loads you're going to deal with.
Yeah. Yeah. It seems like also in aerospace, they'd probably be doing a lot more testing, right? Smaller scale. They
Oh my
can, yeah, they
goodness.
can shoot something, but with like bridges and buildings, you can't just make a mock up of
And
the
that and
building.
that's the point I would make too. So I gotta just to come back to our side and give us props, right? Like we don't have the privilege of building a prototype bridge. Like if it's full scale, it's the bridge that is the first version, right? It's not like we can kind
Yeah.
of say, all right, well, let's go back and do another version that we take that out of service and put it in. You know what I mean? Like
Yeah.
every bridge is a prototype.
Yeah. And I know you recently got into forensics. How's that going? And what are some of the interesting challenges that you've worked on?
Yeah, and when you say recently, for sure, like and from a formal standpoint, but really I've been doing forensics for a while because my bridge engineering uh work involved a lot of inspection, in service, rating, determining how much load capacity is left and things of that nature. But yeah, the nature of my work has changed now to where I operate a little bit more on a one-to-one basis and in more spaces than just the transportational realm, right? You're talking about commercial buildings, residential buildings. Sometimes it could be transportation related. Sometimes it could be, natural wear and tear. Sometimes it could be a weather event. Sometimes it could be, fire. Like all of these things could happen and it falls on the area of forensics. And so forensics is really pushing the mindset around of, okay, how well are you able to decipher and investigate and determine what took place within the structure, right? And I love it because you see these shows like CSI, which is like
Yeah.
forensic crime scene investigations. This is the engineering version of it. So we're like looking for clues on every project to help us sort of reconstruct what took place and determining sort of the cause or the origin or whatever the case may be for what we're observing. And I have to say, I like it. I like it. I do like it. I think an advantage of it is, when you're designing, Matt, you gotta make sure you design because a lot of people correctly, because a lot of people are going to be dependent on it. If it fails, it's not a good thing. Forensics is on the other end of the spectrum. Well, hey, look, it already failed, so this isn't necessarily. I gotta design this just right, but I do gotta use my expertise to determine the why and how it failed.
Yeah, and I think it's similar to, well, in terms of design, design, you kind of see what the end goal is, but I'm assuming in forensics, yeah, you're uncovering that story. It's you don't know what the answer is.
Yeah,
You have some
right.
guesses, but that's when you get into the nitty-gritty of it.
Absolutely, absolutely. You're uncovering a story, and then hopefully, well, not hopefully, your job is to, at the end of the day, tell the story that you know people who discovered or experienced the catastrophe or the failure couldn't tell on their own.
Yeah, and why do you think? Because I know, in the past couple of years, there's been a good amount of headliners for structural failures that have happened throughout the world, in the U.S. Why do you think these failures and forensic investigations, these seem to resonate a lot with well, obviously the technical engineers, but also the
Yeah,
public. The general public is really interested in that. Like, why do you think that is?
that is a good question because I have noticed that too. Like engineering shows that talk about catastrophes and disasters, they do extremely well, right? And there's always an iteration of it. And I think part of it is because you never heard people like it's hard to like look away from a car crash or it's hard not to,
Mm,
to
yeah,
see a fire burn. Like there's just something I think about, wait a minute, that's not supposed to happen. That is just attention grabbing, right? For one. And then two, I think people it almost like, okay, I don't want that to happen to me. So let me see what's going on in this situation. So if I see any similar warning signs in my scenario, I know I need to get out of there, right? Or I need to, so it's almost like cautionary tales that people also are looking for too. So I think it's a combination of the two.
yeah.
Yeah.
And when those things happen too, I always think about like, oh yeah, cool. Structural engineering is getting some publicity, national publicity, but I don't know if it's the best publicity, right? Where like something collapses and it's
Yeah,
like,
yeah, yeah.
oh, okay. Now
Well,
it's like,
Matt, it's funny too though. It's like when we are most invisible, those are the times that we're really doing our job the way it's supposed to be done. You know what I mean?
yeah,
Like it's almost like to do our job well is to be taken for granted. It's
yeah,
wild. But when somebody screws up, or it's not even somebody screws up sometimes it's natural disasters, right?
yeah,
And when things like that happen, it's like we come into the focus during the times of chaos, right? But times where things are just at ease, everything we're supposed to be working, we're still working hard, but no one's really thinking about us. You know what I mean?
yeah. I think that's the way it should be when everything's
Right.
going through. But then, oh man, but then I know friends and family, they come up to me too, and other engineers where like, oh, some natural disaster happened and like a building fell down.
Yeah.
Like I think like recently, like some of the earthquakes in oh, where was it? Myanmar? But no,
Okay.
Thailand, Bangkok. I
Taiwan.
think,
Yeah. 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 Okay.
yeah, one of those like buildings fell down, and then that's just an example. But then friends and family will come up to me and be like, What happened? Did our building safe, etc." Like
Right.
what are some of your guidelines for responding to those without like trashing the profession? You know?
Yeah. No. I mean, we all get those questions, right? I get them all
Yeah,
the time, right? Even in cases where like it's clearly not the engineer's fault, right? It's not an engineering issue. Like this was just a once in a gazillion time, whatever, right? Um, but you asked a good question. How do you talk about it without trashing the profession? I think the key on that though is to focus on the mechanics behind it. You know what I mean? So let's just say I-35 in Milwaukee years ago collapsed and they rebuilt the bridge over I-35 bridge, like 2007 or whatever. And that was a very popular one. And the reason why it failed is because the gusset plates, the connections between the steel beams was too thin, which is a design situation. Now, disclaimer, I'm not pointing the finger at anybody on this podcast, anything like that. But the point I want to bring up is you can go one or two routes of talking about that, right? You can start saying what a person should have did, should have not done. Or you can say, hey, this is the type of stresses this type of member is supposed to hold. And when this member begins to feel stresses, it needs to be, you know, a certain geometric size. If it's not, this will overpower that. And then you kind of have this catastrophic or not catastrophic, this sort of like redistribution of the load once this thing fails. And so like you can tell the story from a mechanic standpoint without having to like point the finger at people. And I think that's one of the ways that you can avoid like traffic profession because I think you're just giving a lesson at that point. You're just giving a mechanics and materials lesson, right?
yeah,
Um, and then I think the other thing too is even in talking about individuals, I think there are always stories beyond the who done it. Sometimes the stories are who did this matter to? Why did it matter to them? You know what I mean? Why do we, as structural engineers, take our job seriously because of how it impacts these people and things of that nature? So I think there are different angles that have, over time, in my opinion, become a little bit more natural in the ways that we and I talk about it.
I like that. It's focusing on the problem itself and explaining it in a way that more of the general audience can relate to it and they're more educated about engineering and what happened about it versus
Yeah,
just, oh, it's XYZ's fault or contractor's fault or engineers,
right.
architects. Because I guess you don't really gain any lessons from that except, oh, architects, contractors, engineers, they're all bad. They don't know what they're doing.
We let them handle that in court. I'm not trying to
Yeah,
litigate.
yeah,
You know what I mean?
exactly. Those things can
Yeah,
last. Um,
yeah,
Everyone gets
yeah.
dragged into those.
Man, I tell you, and even now with forensics too, because 9 times out of 10, there are sides to every situation, right? And there are different desires. But again, my job is not to try to say, you're right, they're wrong. My job is to say, from an engineering standpoint, this is what happened. From a physics standpoint, this is what occurred. This is how it can occur. This is what is consistent with. And then, you let the other folks fight out do the finger point. You leave the finger pointing to other people.
Yeah, you tell the story of what happened, what the problem was, on how it failed, not necessarily
Mhm.
whose fault it was.
Exactly.
Well,
Exactly.
I believe those take a while. I know just like the Florida condominiums that collapsed. I went to a seminar I think last year or so, and it's still going on, and you can see all the
Yeah.
work that they did with those. Yeah, like literally every is it something like that where it takes a while to figure it out because depending on the project, obviously.
Yeah, it could take a while. I think first I was thinking you maybe been talking about like the reconstruction of it, which is a whole nother phase, right? And I guess in theory, they don't one doesn't have to end before the other begins, but it can take a while because you don't always have easy access to how things were in their perfect state, especially if you call it after the fact. You know what I mean? It's not like everything has perfect as built drawings. You know what I mean? It's not like everything has
Yeah.
um it's not like everything has a single cause of failure either, right? Sometimes there's sort of like, yeah, this thing wasn't new already, and there could have been some degradation just through natural age related wear and tear. Um, but trying to get in there to distinguish, okay, this was age related, and then this was weather related, right? Or trying to figure out where those lines are can be very difficult. And so you find yourself doing a lot of research and looking at a lot of different angles when the answer isn't as clear. Sometimes the answer is clearer than other times, but yeah, it can take a while if it's not as clear.
And I did want to talk about some of your involvement in social media content creation. I know it's very important to like for this podcast, for example, like getting information out there about engineering. What can typical like regular engineers do to help with that instead of just relying on others, maybe the media or other professions to talk about engineering versus the engineers talking about it themselves?
Yeah, that's a good question. So yeah, you mentioned earlier STEM Media, which is my educational media company for science, technology, engineering, and math. I think for us, the focus hasn't always been just simply educating in terms of like breaking things down from a technical standpoint, but rather we're more often presenting it in a form that people can relate to. People who may not see themselves in the space, almost creating a scenario, an engineering scenario where a person looks at it and says, I can see myself in that picture. You know what I mean?
Yeah.
That's acceptable to me. And I think engineers, all of us can do a better job of becoming more accessible. And I'll tell you why that can like easily not happen by default. And that is because A, we go through a lot of schooling. B, the way that we're talked about is sort of like, okay, engineer, that's what the engineer said, right? The engineer said it's almost like, in some cases, it can almost be like, if the engineer said it, don't question it. And I think that can have a counter effect on people feeling like they can access it and reach it. Because if ultimately there isn't any type of like engagement around the thought process, okay, who is this engineer? Who is this person behind the curtain, right? It can become more and more at a distance. It can feel more and more aloof. But social media gives us opportunity to say, hey, I just watched this Final Four championship game. I'm really mad that the guy didn't get his shot off. Um, and I'm trying to get my report done. Right?
Yeah.
And I should have been done, but now I got to stay up 2 or more hours past it. Right? It's just different things like that that I think, even though it doesn't go into the technical details of engineering, it at least allows what I do as an engineer become a little bit more relatable to the people who see the content.
Yeah, I think that's the key word, relatable, right? It's not
Mhm.
just engineer. It's, oh, this person has different dimensions. I can talk basketball with them or talk about anything
Right,
else. They're not
right.
just like some stereotypical nerdy engineer doesn't talk to
Yeah.
anybody. And
Exactly, exactly.
and I think that's I know you mentioned also, seeing yourself in that. And I think what I tell other people too is like, yeah, you should share it in LinkedIn, or if you want, on your other social media, because even though, because I know I've always thought like social media, I never really liked using it like back in high school, which is like,
Yeah,
yeah, years and years ago. I don't want to age myself, but it's just like, yeah, I never used to like it. But then when I got into the profession and seeing that, engineers needed to be seen more in terms of like that,
yeah,
that was kind of my encouragement to others too. Is like, yeah, share the stuff that you're doing. It's cool, and
yeah.
you can still go on with your life. But when people see that right online, because you don't know who's watching your content or
Right.
looking at your posts, it'll be like, oh, this was really cool. And maybe I know for women in engineering, I know, since one thing that resonated with them was they would see more and more women engineers, right, in leadership positions,
Right.
and they wouldn't have that subconscious doubt on, do I see myself in that position? They already see people in that position
That's
that
it.
are similar to them, and yeah, getting more exposure like that, whether it's social media or whatnot, I think that's, yeah, it's a good way to go
And
because I
you
think
don't
it
have
can
to be
inspire.
absolutely, you don't have to be an influencer per se to do it too, meaning like a social media influencer. Sometimes it's just the people in your network that just haven't seen it, right? Sometimes it's
Yeah,
just the person that your neighbor who has no idea what you do. They just wave at you, you know?
yeah.
Right? So it's like we all could be a micro influencer to some extent, right? By opening up people's eyes and revealing things about what we do as an engineer and in our profession that they wouldn't have known otherwise.
Yeah, and I think a lot of us take for granted what our projects, how cool our projects are, because maybe you're in it day in, day out. But then to someone that hasn't seen it, it's like, oh, you do what? What?
Yeah.
How are you doing that?
Yeah. 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 You're so close to it. Can't see the forest for the trees. But other people are like, wow, these are some awesome trees.
It's like, I just grow them every day. I don't know what the big deal is.
Exactly. Exactly.
And yeah, Dr. Nee, I did want to thank you. I did have one final question. I just wanted to ask you if you had a final piece of advice for structural engineers uh, in general, or engineers in general, about making a broader impact and sharing their expertise.
Yeah. 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 I like to say one of my favorite quotes says, you know, the greatest investment in your life is in something that would outlive it. And I think one of the things that is very possible for us as engineers is to design something, to build something that might very well outlive us. You know what I mean? Maybe there's a bridge that's going to be around when we're done. There's going to be a building that's gone, a tunnel that's built that still exists even when we're gone. But I also think about that in terms of people as well, right? There's someone, whether it's that intern in your office or whether that neighbor that we just spoke about that waves at you, there is a way to build something in the lives of others that would outlive you. And I think that is an incredible investment that we all should make.
Yeah, it's beautiful. Yeah, thanks for sharing that.
My pleasure. My pleasure. Thank you for having me.
Yeah, absolutely. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.